Like everything will start blooming, all the trees will bloom, it'll all be beautiful, and then we'll get like a foot of snow that crushes everything. All right, we're sorry for the late start. Sorry, but guess what? You hit the jackpot by showing up today.
Oh God.
Here we go. What are we building? Not much. No hexaflexagons. We're doing something today called computational origami.
Do I need to run to sociology?
We do not. We don't need no scissors, no tape, no glue. We don't need anything. We just need some paper. And to make this up would have been a nightmare. So you get like a bunch of credit for showing up today, playing along. And grab a pen. Onward we go. All right, friends. So as promised, one of the greatest things I've ever learned in math, we are going to do today. And it is called Fujimoto's Approximation. Ooh, am I recording there, Abby?
Yeah.
Yeah? Okay. Fujimoto's Approximation to 1 over n, where n is odd. So in other words, n would be 3, 5, 7, 10 dead. So this was in the 70s, this was discovered, and it's a part of something called computational origami, which sounds like, you know, some silly math thing like underwater basket weaving or something like that. But it turns out that origami has become incredibly useful in physics and in space travel. So have you ever heard about the solar sail that they're building? So one method of traveling, interstellar travel, is, you know, you've got the sun and it's sending off a solar wind. So there's like stuff coming off the sun, right? It's like particles, it's not a normal wind, but there's a solar wind. And so one method of space travel, interstellar space travel, is to create a giant sail and have a ship behind it. And it's like, the ship is here and there's a big sail that will catch the solar wind and travel out. So how do you get this giant sail out into space in the most efficient way? And one technique is to use origami to find the most efficient possible folding of this sail so that it can be nice and compact and with the fewest moves, the least energy, unfold. It's not exactly what this is going to be, but it's part of computational origami. And origami is hot, man. It's you're going to probably be hearing more and more about it in the next couple decades, certainly in your lifetimes. But this is more straightforward. We're not going interstellar travel here. We're doing something simple. So let me start off with a quick question to you. If you take a piece of paper, everybody grab a piece of paper. Okay. How do you fold this into perfect thirds? So what would be your technique? If I said, I need this folded into perfect thirds, you know, this way, so the folds are like this, how would you do it? Tips. Like, you know, like you do this when you fold letters into envelopes, right? You kind of, what would you do, Paul?
When you fold it like that, and then...
Paul's got some moves, man. What are you doing?
I think you showed us this like last time.
Did I show you
yeah,
this?
So. Something like that. And it has to be like perfectly meet this corner, but...
So what's the rest of it? So that'll make it a perfect square, definitely.
I don't know anything.
How'd you get that? So sorry. So this might have been headed down somewhere really cool. I don't remember talking about that, but I remember doing this just to get a perfect square.
Okay. I don't know.
Okay, cool. Fair enough.
We did do that to get a square.
That was how we did. So what did you do, Abby?
I just folded it.
So you did like this is how you do it, right? You like go, and then you try to finagle it, right? And you work with it until it works.
Gotta get the creases.
You gotta get the creases right. But it's a guesswork. It's pure guesswork, right? And it's not an exact thing at all. So in 1979, I think approximately, Fujimoto, a Japanese mathematician, who's really into origami, came up with a technique for making folds into, so like folding things into thirds, fifths, sevenths, on up. And the method itself is really cool, but what's going to come out of the method relates to everything we've just done for the last week and a half with binary numbers. So I want to show you this method, which you can show anybody, and it's really cool and pretty straightforward. And then we're going to look at, holy shit, what is happening here? And you're gonna be amazed. So let me show you Fujimoto's method with no further avail. So here's your piece of paper. Now let's walk through this really quick so you can see the rhythm. First thing is I make a guess. So this is an approximation. So we make a guess, and let's say I guess that this is my fold line. So I'm going to do this while I go through. Don't do this yet, we'll do it together. But I take my piece of paper and I say, okay, I'm going to do a really bad job at this. That's a third. Pretty bad, right? Like more like a quarter. So I'm going to make a little pinch. Look at what I'm doing. So see how I'm not creasing the whole thing, but I'm making a little cinch right at the top? So that's my estimate right there. So in my mind, this is one part, and then this is two parts, right? Because I've cut it into thirds. So this is 1/3, and this is 2/3, in theory. So now check this out. This isn't a true third. I don't really have a true third. What I have is some error. So I have a third plus some error. So I'll use E here for error instead of Greek letters, just to make things a little less freaky looking. So this is a third plus some error. If this whole thing is 1 unit, or 1 length, how much is in this remaining part? It's going to have some error on it. And I need this plus this to be 1. So what is this length here? We can figure it, right? So it's 1 minus this side. So that's 2/3. Might just distribute that minus, 2/3 minus E. Let me stop there. Does that make sense? Because it really needs to make sense. That if this is 1/3 plus error, then this is 2/3 minus that same error, so that when I add these two lengths together, I get 1. Notice the errors cancel. Okay, yeah, cool. So now this side here should be divisible by 2, because it's 2/3. So I could cut this side into half. So my next move is to take this right side that's 2/3. So let's come over here. So here's the next step. Right now I'm here, and I'm going to take this side and fold it over. So I'm going to fold this side in half. I'm going to take this corner and bring it to my previous estimate. And that's going to cut this side in half. So let me show you the move so you can visualize this. So here was my first estimate. Here, a little crimp. So now what I'm going to do is fold the 2/3 side in half, make a crimp. Notice how I'm not making the whole crease, I'm just crimping. And so now I've got that little estimate right there. So check out what that is. This whole distance here was 2/3 minus the error. What's half of that? What's half of this number? No, if it was a third, it would be a sixth.
Oh.
But, so, what's 2/3, what's half of 2/3? We'll just distribute this. So this is 1/2 times 2/3 minus 1/2 E. So this simplified too. We don't usually do math like this in here. What do you think, Paul? What's half of 2/3? How many thirds are there in that? How many thirds are there in 2/3?
1/3.
1/3 is half of 2/3. Yeah, exactly, exactly. So this is 1/3 minus half of e. So that's what this length is here. 1/3, sorry. 1/3. If this whole thing is 1, what is this length? It always has to add to 1. What is that length right there? I'm glad you made it.
I messed up. I thought you said that we had Zoom today, but
Oh.
then I realized it was a different professor, so I sat on the Zoom
Oh
for
shit,
5 minutes
okay.
thinking it
Oh
was
no, I'm glad you made it.
you. Me too, I'm so sorry.
It's okay. This plus this has to add to 1. In other words, this distance here is 1 minus this left side. What does that turn into? So 1 minus 1/3, you distribute the minus, plus e over 2. That's 2/3 plus e over 2. So check it out. This side is 2/3 plus half the original error. Now this side has got 2/3, that side has 1/3 plus some mess up, but just think about the rough estimate that we're shooting for. If I now take this corner and bring it over to this side here, I've cut this piece in half, and how long is half of this? How long is half of 2/3 plus e over 2?
Would it just be 1/3 plus e over 2?
Be 1/3, because half of that is 1/3, right? Plus e over 4. Does that make sense? Half of e over 2 is e over 4. So now, this is 1/3 plus e over 4. And you think, okay, big deal, I've still got error. What was the original error? Our original estimate had this, we don't know what the error was, but it was off by this much. After this process, we've cut the error by 25% of its original value. So I've cut the error by a factor of 4. 2 folds, that's all it took. So check this out. So all right, so here was my first estimate of 1/3. I pinched pretty bad. So now it's 1 and 2. I bring the 2 side over, make that crimp. So now this should be 1/3 and this should be 2. So I'm going to divide the even side in half again and crimp. And now this is my new estimate. And I'm going to show you how it moved in. So here was my original, and then here's the new one. I want everybody to see this. Here's the original, here's the new one right here. So the new one's to the right. Yeah? So you can see first estimate bad, second estimate much better. Looks like 1/3 almost. First estimate, second estimate. First estimate, second. It moved over, right? So the key thing is that first estimate was bad, and I'm improving first estimate, second
So
estimate.
it's still just an estimate, right?
It's still just an estimate. Yeah, exactly, Paul. And depending on how bad first estimate, so you missed the first part, but we'll do this again, so it'll come clear. So let's see, that was my first one. That's the improvement. Okay, so like Paul said, it's still just an estimate because there's still error. If I had made this perfect, the error would have been 0 and I wouldn't need any of this. But what I've done through a series of 2 folds is improve my error by a factor of 4. How could I improve now I've got this new estimate, how could I make this new estimate better? So okay, let's just say, start with this new place that I ended up at, it's way better. I could just repeat this process. So watch, I'm gonna repeat the process now. So here I'm gonna take that as my new estimate. Let me actually mark this with pen so you can see it. So that's my new estimate. So I fold over, this is supposed to be 1/3, 2/3, so I fold the even side. And I'm really making a big deal out of saying that because that's gonna be the key to this scheme. So I fold that. Now this should be, so here I've got that little fold right there. That should be 1/3 and this should be 2/3. So I cut the 2/3 side in half. come over here, and that is actually improved again. That it's slightly different here, right here. Here's my new estimate right there. So look, first estimate, second, third. And this third one, each time I do this, I decrease the error by a factor of 4. So this new one has 1/16 the original error. A fourth, and then a fourth again. So holy shit, just 4 folds, and I've improved my estimate by a factor of 16. That's really amazing. Let's actually see how good it is. So now I can complete the fold, and I should be able to fold this piece of paper in thirds using that. Let's see here, just how good it is. Now remember, my original estimate was pretty bad, so see, I've got some error still up here. That's the amount of error that I still have, so it's not great, but the original estimate looked like this. Here was my original third. That's like literally like a quarter or something. So let's see, how many times could that original? Maybe a fifth, for God's sakes. Holy shit. All right, so what was that first? So my first estimate was 1, 2, 3, 4, like a fifth, somewhere between a fourth and a fifth. My new estimate's way better. So this process of just simply folding, usually what happens in math or just physical systems is you've got some error, and then the process keeps going and the error multiplies. This is a rare process where the error diminishes as we keep going forward. So let me show you how this would work with, actually let's make a little table over here too. Let's keep track of the folds. So when we did a third, let's see, so fold sequence. Because this is what's going to tie it into stuff we've done.
Wait, I have a question.
Yeah,
Just so I'm clear.
please.
So basically, you're going to continue folding the piece of paper, or like the sail or whatever, until you eliminate the amount of errors.
Yeah, until you get it to within a place where it's good enough for you. I mean, that's what approximation's about. That's what, you know. So you keep doing this until it's within. Eventually, like if I did this one more time, Abby, it would be another factor of 4, so my original error would be diminished by a factor of 64 if I just did this 3 times. That would probably be hard to distinguish just because there's error in our folds and the piece of paper's only 11 inches wide, so it would probably be almost like a hell of a accurate 1/3. But it'll never be precise unless your original is precise. Let me show you this again. Wait, so actually, let's think about how this works. So remember how the folding sequence worked? I made my estimate, and I had 1/3 and 2/3. This was my initialization, and then I folded the right edge of the paper over first. So fold sequence was R, and when I did that, I had folded this in half, and then this was 1/3 and 2/3, and then I folded the left edge over, and that got me back to the 1/3, 2/3 scenario. So thinking of which edge of paper we fold at each step, this was first fold the right, then fold the left, and you're back to your start. I'm gonna leave that there. Oh, so this should be 1/3. This is the one overhead that we're trying to approximate. Let's do another one. Let's talk about a fifth. So let's estimate a fifth. Actually, before we do this, maybe try the 1/3 on your paper. We should really see this. You got to see this in action. So take your paper, make a guess, and make a bad guess. You know, make a bad guess at a third. And let's do this together so that you get the rhythm. So that's that's like a 1/10 almost. So make that little pinch at the top, just a pinch. You don't want to do the whole fold because it's not the truth or anywhere close to it. Then you fold the even side over and make a little, see how I'm running my finger across and cinching right there. Make a little cinch. Once you do that, then you should have 1/3 on the right and 2/3 on the left. So you cut the even part in half. Bring the left edge to that right hand crease. Run your finger across the top, just kind of pull it across, and you'll get a crease. That crease is a better estimate of 1/3 than your first. So see if you can see that. Oh, you need paper.
Thank you.
Yeah, sorry, Bella. I live sorry. It's like the I know. It's what it's like I've been working on, right? It's like no sorries. Fuck that. I'm not sorry. If you want, now try it one more time with your new estimate. So take your new estimate, improve it by pulling the right edge to that estimate. Cinch. Pull the left edge to that cinch. And now you can actually see on your own paper how the estimates kind of crawl across to the right edge, or to the right third. Is it working? Yeah?
No.
Yeah, maybe. Oh, so let me see. So you did, what was your first one? This?
Yeah.
You did
I'm cinching.
cinching. Yeah, you cinched like hella good.
Thank you.
Yeah, no, it's a fine cinch. So
That's
that's
a
your
first
second
for me.
cinch. That's your second cinch.
Yeah.
So wait, this was your estimate. Okay, then there, yeah. Okay, so that's your second. So now bring this over to that, and something. Yeah, I think.
I felt like something went wrong.
Yeah, I think so. Let's start here, right? So make my estimate.
Okay.
Make my estimate, and then this should be 1 and 2. Fold the even part in half.
Yeah, one more.
Cinch.
Okay.
Now left edge to that cinch.
Cinch.
Cinch. And that's when you estimate.
Oh.
Yeah, you see how that works?
Yeah.
Okay. Anybody else need help? You doing good, Frank? Think so? You sure? You wanna talk about it, or? Good.
I think I'll be.
You, all right, man, I'm gonna trust you. You know, you good? Outstanding. All right, you doing good?
Yep.
Making sense? Yes, ma'am.
Okay, so I feel like I'm going back to the
Maybe so. So is this your first estimate?
Yeah.
Okay. And bring right edge over. Cinch. So let's see. So that's my cinch. Bring the left edge to that. You're doing great.
But then after this.
Oh, so if you want to do it again, now that's your new estimate.
And like, isn't there something over there?
It's because your first estimate was so damn good. Like, yeah.
Oh,
I mean,
oh.
seriously, like, there's a slight improvement in that next one, see?
Oh, okay.
But you did a really good estimate. James, how's this working for you, friend?
Thank God.
Is this making sense? Yeah? Okay, awesome. Enrique, how are you doing, friend? You testing?
Yeah.
Testing your thirdness? Awesome. That looks pretty good. Bella, is this making some sense?
Mhm.
Outstanding. Outstanding.
I feel like I did this in ACT prep for whatever reason.
I would be shocked, but that might be. But maybe.
Cause we did some shit like this.
Yeah, I don't doubt that.
And it was like how many times would you have to fold the paper
Oh.
in order to have like,
Have it be a stack like a mile high or something?
no, like this, like how many folds in the paper.
Huh. Maybe. Maybe.
I don't know, but I also sucked at the ACT.
So, okay, well.
Which is funny, cause math is actually one of my strongest
You're doing great in this class.
scores.
You are doing great in this class. Let's do a fifth.
I know, thank you.
You're welcome. You're doing it all. All right, so let me show you how fifth works. And this is a little more complicated. But it's the same idea. The rhythm's always the same. You just have to understand you're always folding the supposedly even multiple part. So I want to do a fifth. I make an estimate. So this should be 1 and 4. 1/5 and 4/5. Yeah? So this is the even side. So check this out. This is the initialize. So initialize equals make a guess. Now we start thinking about the process. Which side am I going to fold? Left or right? right side because it's even. I'm always going to look to split the even multiple side. So here, I'm going to fold the right edge, and when I do that, I don't need to draw this whole damn big piece of paper, but that'll cut this in half. What number will be here, Lydia? 2. And then what's here? How many fifths? 2/5 here.
3.
3/5. Yeah? So it always adds up to the total number of parts I'm trying to cut this thing into. What side do I fold again? Which one? Sorry. Which one's even? Right edge. So I'm going to split the even part. So I'm going to fold the right edge in, and what will this be? After you cut this in half, how long is it? 1/5. How many fifths are on the left then? 4/5. Let me stop, because if you don't understand that, the rest of this is not going to go anywhere for you. Please let me know if this is making sense. What side do I fold next? The left, the even side, right? So I'm going to fold L, the left side, and what's going to be in this box here? How many fifths? 2, and then 3. What side do I fold?
Left.
Beautiful, thank you. Nice, solid, confident, left. And that gives me 1 and 4. And now I'm back to the original. So every time I do this, it cuts the error in half. Every time I do this, I'm diminishing my original error. So if I had an error here of E, so you might be like, what are you talking about error? So 1/5 is 0.2. So if my fold actually was like, oh, I folded it at 0.27, I mean, I have no idea what I folded it at, but it's probably not exactly 0.2. If it's this, my error is the difference between those two. It's just the difference in what I want and what I have. So here would be like an error of 0.07. All right, so what is the fold sequence here? And let's actually try this 5th on our own with a piece of paper. But the fold sequence is RR, LL. Okay. Can you do it? Let's do it. Let's make a guess at a 5th and improve your estimate. And since you're folding in fourths, halves, this many times, you improve your error by 16 times. Or diminish error by 16x. So boy, whatever that first guess is, after this process, it's going to be beautiful. I don't think you'll find anything on your phone there, Frank. Right on that paper. Make a bad guess. The worst guess. So then remember how it goes. It's going to be RRLL. So you're going to fold twice to guess. Fold to the first guess. Fold to the second crimp. Now you've got that right end crimp, and go to that from the left. And then you got a new crimp, to there from the left. And I will bet you that's pretty damn close to a 5th. Because the whole piece of paper, 11 inches, your maximum error is 11 inches, let's say 5 inches, because you're really a wild ass person if you fold it across the halfway mark. So 5 divided by 64 is really fucking tiny. Anybody got a calculator on?
Whoa, what is it?
What's 5 divided by 64?
Like 3.4.
0.12, that's, yeah, little under 0.12, yeah, let's give it a shot, like 0.11. So,
0.078.
Oh shit, okay, so, your estimate should be within that much of a fifth of the paper, and that is pretty damn good. I'm gonna check out mine, cause my first guess was horrible, so you can always accordion things to test to see how good you did. Oh man, mine is so freaking almost beautiful. Not 100% beautiful, but pretty 50. How's your going, Abby? No? No? How's yours going? Oh, yours. It's beautiful. That's really beautiful, Frank. No? Let me see it. Oh, Lord. Right, do it again.
I was like,
Make an estimate.
I was overthinking.
Does that make one complete or? Oh, I love it. I think if you wanna make them complete, go for it, but man, it looks really quite amazing. So let me see your first guess. Where was your first guess? Oh, you,
I'm making my first guess right
oh,
now.
okay, alright. Crimpy, you're gonna crimp. You're really crimping the hell out of it, good. Okay, so, alright, so that's your fifth. So then,
Yeah,
this
and
is
then
1
we
and
got-
4, so cut 4 in half. Beautiful. Yep. 3 and 2, you just cut 4 in half. Fold that over to there. Quarter it up. Cinch. Perfect. So now that's 1/5, 4/5. Now we work our way back. Cut 4 in half.
That's what I was.
So now now this should be 2, and then 1, and this is your estimate, and it looks pretty fucking good. But you can compare to Frank's, because Frank's got like some gold standard shit over here. Is it, you want me to show you this? Yeah, okay. That's great. Why not? I think, it's hard to tell unless I do, but, so make a guess. Let's do a guess, okay, so there's my guess. So now this should be 1/5, 4/5. So I cut this 4 in half. So now this should be 2, 3, does that make sense? Cut the 2 in half, always cut the even in half. 1, 4, this is 1, I think it's a little bit, 4 over here, cut 4 in half. You work your way back to the original side you were on. So now this should be 2/5. This is going to be an improved estimate right here, because I would have about 1/5, right? So what was it, I forgot? Pretty good, right? So it was a little overshot, we were over a fifth, but now we've improved it, we backed up enough. That's probably hella close.
Right.
Yeah, so that's enough, that's it.
Wow.
Yeah. Anybody else need help? Anyone need help, or are we feeling it? I'm seeing lots of fifths, that's fantastic. I don't know, let me see you do it. Okay, estimate, all right. Cut the 4. Yeah, cut the 2. Beautiful. Yeah, that's nice. Yeah. And then so that should now be 2/5. That should be 2/5. Now cut that in half and go back. And so yeah, so it'll creep over a little bit from your previous one. I'll hold that for you. But see, you had a really good estimate. And so now that new estimate, so that should be ridiculously close to the
Okay.
5th. Yeah. James, is this going well for you, my friend?
Yeah.
It looks good. Looks real good. Enrique, you feeling good on this?
Yeah.
Looks good. Paul?
Yeah, I'm good.
Awesome. So here's a puzzle. Let's do a 7. Can you do a 7? And I'm gonna help map this out. Let's see if we can walk this through. You guys tell me what to do here. So here's how you can map out the folding sequence. You just need a little line, and you say, okay, if this is 1, I'm gonna go 7ths. So this would be 1 and 6. right? So which side do I fold? The 6, the right side. Yep, cut the even part in half. So a right fold. What are the numbers going to be?
1, 5, 1.
What's 6? What's half of 6? 3. So when I cut this in half, this should be 3/6. And how many 6ths on 7ths? Excuse me, 3/7. How many 7ths on this side? 4, because they have to add up to 7. So now what side do I fold? Left. What are the numbers going to be? 2, beautiful 2, but then we need to add up to 7, so 2 and 5. Does that make sense?
Yeah, I was just.
Cool, you're computing. Now what side do I fold? Left. And 1, 6, and I'm done because I'm back to the original starting place. So check, 7th was really nice, right? And let's write a couple up and do this before we fold them. So 1 7, and the fold sequence was R L L. Cool. Let's do a 9th, which is exactly something you did. Oh, by the way, I need to collect those assignments.
Yeah, I was
just
gonna
remembered.
say that earlier.
Yeah, I'll collect those. Yeah, you can still turn them in on Wednesday, as so many people will have to do, I suspect, based on the sounds made when I mentioned that. So I will still collect those on Wednesday, start of class. So 1/9 was something you found the binary expansion of on that assignment, in theory. In theory, you found the binary expansion of 1/9. But let's do the folding pattern. So, make my guess. 1 9. Oh wait, 1 8, right? It's all got to add up to a 9th. What side am I folding? Right? What are the numbers? How much is this one? And then 5. What side?
Right.
Right? What are the numbers?
2 and 7.
Yep. 2, 7. What side?
Right.
Yep. What are the numbers?
1 and 8.
Beauty. What side am I folding?
Left.
Beautiful. What are my numbers?
4 and 5.
Nice. What? Tell me what to do.
Left.
Beautiful. 2 7. Almost home, right?
Then 1.
Left again. 1 8. And we're back to the start. So fold sequence was R R R L L L.
This kind of sick.
It's kind of cool, right? Oh, that's a good answer. Oh, that's the shit that gets me out of my bed and into the classroom.
Wait,
good.
what? I'm confused what just happened. Was there something on
Your
the wall?
reaction was.
But your reaction made me happy.
Oh, I thought there was something on the wall.
So
that you
let's
were
not
referencing.
let's pretend I understood it the way I did, and not what it might have been that you saw a bug on the wall.
No, I
Okay.
thought you saw a bug on the
Oh,
wall.
okay. All
Because
right.
you were like gesturing towards that way, and I was like, "What's on the
Well,
wall?"
I mean, I'm gesturing all over the place all the time. Can anyone give us what was the binary expansion of 1/9 off your paper? What was that binary expansion?
I think it was 0 0 0 1 1 1.
I think you are right, Paul. So in binary, so this is when we convert that to binary, it was a repeating decimal, right? So it was 0.000111, and that was base 2. Those aren't decimals. Look at the fold pattern.
Well, are the R's zeros and the L's ones?
They sure are. Yep. That is correct. So, when we do these folds, we are literally computing the binary expansions of these fractions without even knowing it. Isn't that fucking crazy? I find that just absolutely amazing. So, 1/7 must be,
0 1 1.
yep, 1/7 is equal, and that's repeating, right? And what's the repeating for? Because now we're back at the start and we could do it again to keep improving. So that you could just repeat and take that decimal, that binary thing out as long as you want. So 7 is going to be, yep, 0.11.
Or it's,
Oh, sorry, yes, thank you.
yeah.
Good call. That makes me happy.
0,
For the 1/7, 0, 1, 1, and then, yeah, what is 1/5?
1, 0, 0, 1, 1.
Yep, exactly. So, last thing you got to do for me today, because good news, you don't have to write a paper or give me a personal presentation on this like our friends who've missed it will have to do. So be very happy with yourself. Be very happy with yourself for being here today. We're super happy. Here's what I would like you to give me before the end of the hour. I want you to use Fujimoto's approximation to give me the binary expansion of 1/11. Give me the binary expansion using this folding method. You don't even have to fold, you can map it out, right, with the stuff like this. You don't even necessarily have to fold. But if you could, now when you're on a desert island, you can produce an inch from an 8.5 by 11 inch piece of paper. Man, when society goes to hell, we now can reconstruct the fucking inch and start from there. Work that out, my friends. Get you going here. This one's a lot more interesting. I didn't want to I didn't want to make you stressed or anything, but I was like, this is the truth. Oh wait, you guys, hold on real quick. Sorry, you keep going on that, but we actually need to read these backwards. It's actually, you record these backwards, and then R equals 1 and L equals 0. So apologies for that. I was just looking at that and I was like, that's not 1/7. 1/7 is actually going to be, so you write them backwards, 0, 0, 1. Yeah, so 0.001, that's 1/7. Repeating. Luckily, the other ones are all symmetric, so we can't go wrong with that. Yes. No, there shouldn't be because it's an odd number, so let's take a look.
So
It should be 9. Yes. Does that make sense?
Yeah.
Okay, cool. Yeah. Yep, yes. Is that right? Let's see. So I don't even know off the top of my head, so let's see what we got. Right, and then L, then right. So, yeah, so we recorded, so let's write them backwards, right? So R.
Oh, so it would be
Wait a minute.
1, 1.
So let's see, our fold sequence was R, L, that was an L, right? Oh, so this is an R, then an L,
Yeah.
yeah, then an L, then an R, and then R all the way home. Wait,
I got 0.010111.
yeah, something's. Yeah, there should be more zeros. There should be more zeros because 1/11 is really tiny, so it should be like 0.000 something. So what is going wrong here? So see, we got 110, 5, 6, 3, 8. Yeah, so you got the right sequence of 4, 7, 2, 9, 1. Oh, you got to go all the way back to the other side, Paul. So this is a good estimate.
So I'm like halfway there.
So you're halfway
Okay.
there. Yeah, that's the problem. That's why it was not quite right. Otherwise, it will work. So this one, man, yeah, Oh yeah. Okay, so let's see. This looks really good. So now do it backwards. That's the only thing. So undo it backwards. So it's actually L.
Right, okay,
L.
okay,
Or
okay.
do you know what I'm saying?
Yeah.
So it's just that in reverse.
Okay, cool.
And yeah, so it'll be 0.00010. Yeah, does that make
So
sense?
the L's are zeros.
The L's are zeros, yeah. Because I think of it like zeros on the left and ones on the right.
Yeah, 'cause it kinda just.
Yeah, exactly. It kind of syncs up just like that. Got it?
I believe so.
What's the folding pattern? So that's good. It looks like pretty damn good. So record the L's and R's.
65.
We got to keep them in the right order. So now I would say this is great if you got the pattern down, but do you have a pattern? Let's get a pencil out. Cool. So what I want you to do is to actually kind of almost
Now
like
I
a
think we have the
computation.
same answer.
So
You got
we're
it.
doing 11, right? Yeah. So start with
Hold on, I'm still figuring out this backward.
then you fold the right side,
Right,
that would be 5,
right,
and you do 6 left, and you fold the left.
left, left.
Do you see what I'm saying here? So keep doing that until you get back to this 110.
1,
Does that make sense?
0.
Yeah, yeah. And then record
1,
those.
1, 0.
Beautiful.
0,
That's it.
0,
That is it.
0.
Yeah, it really is. You're like as powerful as the
Wait.
greatest super. Hold on, I'll be there. Yes, and then record backwards. So 0 point. So the sequence backwards is going to be L,
0,
L, L,
0,
R,
0,
L,
0,
R,
0,
R,
0.
L, R.
Okay.
And so then it's 0 point 0, 0, 0, 1, 0, 1, 1, 0, 1, repeating.
Okay.
Does that make sense?
Yeah.
Yeah.
Thank you.
Good. Yeah. Nice. Yeah. So now record the sequence backwards of folds. So L, 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 R, L, R, 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 L, R.
Okay.
So write them down. Oh, that's it. And then put a bar over the top because it's a repeating.
Okay.
Yeah. Beautiful. Nicely done. Enrique, how's this going for you? Yes. Something's a little off here, so let's see. Where's your little LR? Let's start over. 'Cause I think it's
Sorry, I usually do the numbers first. That's how I like, because I missed the class, so like, I had to email my professor from high school.
Oh, really?
Yeah.
Okay.
And so he taught me like, not the letters.
Okay, but this is wrong. That's all I'm saying. So this looks right, but you're not interpreting the numbers properly. So it's 0 point zero, L is 0.
Okay, I have
So
0 point 0, 0, 0, 0, 0, 0, 1.
0, 1. Does that make sense? Yeah? Okay.
That is not.
Oh, thanks. Oh, yeah, and I'll collect those assignments from you if you got them today. And if not, you've got to get them to me on Wednesday or suffer a late penalty.
Oh shit, I accidentally put 1 extra. I have mine.
Huzzah. So you didn't actually do kind of, I guess it's all in there. What does this say up here? Sleeping or working. So I guess it's Yeah, I was so, like, I was trying to be really clear about that.
Sorry.
And what does this look on Zoom video?
Sorry, that was a note to myself.
It doesn't look like an answer. It's not, is it? Maybe you can get me that on Wednesday.
Should I?
Yeah, because that one's not done.
So, what's it now?
Be proud of yourself for
Wait.
converting binary.
Converting 1/9 to binary is literally just this.
Well, you could use this, yeah.
Well,
Or you could
1/9.
do it another way.
I could.
Well, but I wanted you to do it with the method that I showed you in class.
Oh, that's true.
Do you have an extra one of those sheets? I'm
No,
not sure.
but I can put one up and you can print it off, yeah. James, how's it going over here, my friend? How's 11?
Awesome.
Yeah, that looks solid. Too many zeros out here, can't even think, so let's see.
You got the red one, or-
One more R, yeah.
Actually, no problem. Come on, boy.
Yes, so there's only 3 zeros, this is only 3 L's, so it should be, yeah, there's 1 less zero. That makes sense.
That's fine.
Beautiful. Cool, nice.
I'll get a little-
Good work.
$20.
Oh, yeah, you can hand it in on Wednesday, that'd be great. Thank you.
And for me, like Harley does.
Lydia, how's it going, friend?
Okay, yeah, I was trying to do it here, but.
You got it.
Okay.
You're rocking it, you're rocking it. Nice.
Or a year at least.
Yeah, you're good. So, you are free to go after that. And if you have this assignment, I will take it today. Let's see, wait, whose X's are these? So I've got Enrique's, I've got Frank, and Braden's, right? These, okay, awesome.
So you don't want this communication?
No, I checked it, I saw you did it. Yeah, it's just another piece of paper for me to throw somewhere and forget.
That's fair. Wait, we're done?
We're done,
We can leave?
you can leave.
I will.
I'm gonna take a nap.
Good, yeah, go rest up.
You want these back?
Oh yeah, I'll take that extra paper back,
Here's
it's pretty sweet stuff.
Save the
If you
trees.
need it, keep it.